This is Joyful, Happiness Movement and Podcast. I discover the science behind happiness and well-being, and through sharing stories, I am searching for the secrets to a happier life. You can find two types of episodes on our platforms, guest series and solo episodes. In our guest series, I will be meeting with experts who share their knowledge or experiences contributing to a better understanding of a happier life. The solo episodes are divided into series of 5 episodes in each series, as in each episode I will talk about a topic related to one of the 5 pillars of happiness that we've designed at Joyful. If you're curious to know what are those 5 pillars, I invite you to check out our Instagram page. I hope you're ready, as it's time to be joyful. I am pleased to welcome Professor Russell Foster, head of the Nuffield Laboratory of Ophthalmology and director of the Sleep and Circadian Neuroscience Institute at the University of Oxford, in today's episode of my podcast. Professor Foster and his research group were the first to discover the third type of photoreceptor in the eye, namely the photosensitive retinal ganglion cell, responsible for regulating the circadian system by light and revolutionizing our understanding of vision. He has dedicated his career to investigating circadian rhythms and sleep and translating his findings into improved health and well-being. A prolific author, Professor Foster has written 300 scientific publications, co-authored several books on sleep and circadian neuroscience, and recently published a solo work, Lifetime. In this newest book, he presents the science of the body clock and talks about how our approach and attitude to sleep impact our daily life. In our conversation, I asked Professor Foster about circadian rhythms, sleep, and about their importance for our well-being. We touch on the growing issue of sleep anxiety, the role of sleep in our ability to regulate emotions, and we dive into how overall sleep nourishes happiness. Professor Foster is a fountain of knowledge, and I had a great pleasure engaging in this conversation with him. I am sure that you will really enjoy it too, and if you're keen on learning more, I highly recommend you to read his recent book, where he offers a more comprehensive conversation on how to master your sleep while maintaining your cool. Professor Russell Foster, welcome.
I'm delighted to join you.
First, perhaps what I wanted to ask you about is your background. I've learned that you actually finished zoology, which is not quite related to neuroscience or human sleep. So could you tell me about your journey? How did you come to work on sleep and circadian rhythms?
Well, I went to university thinking I'd become a marine biologist. I used to swim competitively and I love biology. Therefore, what else do? You become a marine biologist. And then in my second year in particular, I discovered physiology. And I remember in one laboratory, we were recording the light responses from the eye of a locust. And I just thought this was so amazing. So you can record physiological responses from a photoreceptor. And I guess that was the trigger that got me into physiology, and particularly neuroscience. And so did my degree in zoology, but then went into neuroscience, trying to understand how birds, in fact, detect day length, how they use the increasing day lengths of spring to trigger their reproductive axis. And so that involved studying the photoreceptors involved and all of the neuroendocrine apparatus that triggers reproduction in birds. And so that was part of my way in. I then went to the Netherlands to do photoreceptor biochemistry, Germany to study neuroanatomy, and then went to the States. And that's when really the main chunk of what I do now started, which is trying to understand how the light input pathway to the clock, what does it consist of? And how does it regulate the internal circadian rhythm so that the internal day and the external day are perfectly aligned? So that's a brief story of the last 40 odd years.
Yeah, I
Terrifyingly.
wonder. I wonder whether it was difficult for you to shift your perspective this way. So, was it difficult for you to change the paradigm and go from
No,
zoology to neuroscience, or was it really
not
natural?
at all. In fact, I think a zoological training is really, really important because it gives you that comparative view. So many people just study mammals, for example. And our big discovery, which is the discovery of a third photoreceptor system within the eye, really was informed by my studies on non-mammalian vertebrates and that they have extra retinal photoreceptors, weird photoreceptors in the pineal and actually within the brain itself. So the conceptual leap to think that the eye might have a weird photoreceptor was very much informed by my comparative studies in zoology. So I would urge most biologists to do some comparative work before they go into their specialization.
So perhaps it was even your strength, the fact that you didn't come from neuroscience. It gave you like a wider
I think
perspective.
that's yeah, and I think that's so important. But it really it allows you to think slightly differently, and certainly more broadly
Yeah.
about subjects, and therefore how to answer questions.
Yeah. Then, since you've been working in sleep and circadian rhythms for so long, well, I think it has been like 30 years, right?
It's longer, but
I
that's
didn't
fine.
I didn't mean it to sound this way, but you know what
I,
I mean.
I
It's
know
just that
exactly what you mean.
you
Yes,
have a certain amount of expertise in the topic.
and it
So
surprises me sometime how long I've been working
yeah.
in the field. Yeah.
So I wonder whether you've noticed some differences in how we approach sleep. So how did our approach to sleep change over the past, I don't know, 10 or 20 years?
Oh, it's been profound. So, I grew up within the circadian community, biological clocks. And in those early meetings, and there were like 90 people, I mean, tiny meetings compared to today. And there was a very comparative view of, people were studying timing in pigeons or reptiles or plants. And we had this comparative view of circadian time. We never talked about sleep. Sleep is what the clinicians did with their electroencephalography. And so the sleep and the circadian community really didn't talk to each other for a very long period of time. And it's only really within the last, I suppose, 10 in particular, 15 years that the two communities act synergistically. And I think many of us felt that there's got to be a lot more to sleep than simply measuring electroencephalography from the surface of the skull. And as somebody was saying to me the other day, that trying to understand the brain using EEG is a bit like trying to understand what goes on in a building by looking at when the lights go on and off and the toilets flush. It's a pretty crude tool, I have to
Yes.
say. And I think the exciting thing for me is that the two communities are now working together. So we've done work which has shown how sleep biology changes how the clock responds to light, which is amazing, and how the circadian system, of course, is timing sleep. And neuroscientists like my colleague Vlad Varzovsky have come into the field and are using really cutting edge electrophysiological techniques well beyond just EEG to understand sort of the neuroarchitecture of sleep. And so what he's shown, for example, is that sleep isn't this flip-flop as we always think of it, but he's sort of been one of the pioneers showing that there is local sleep. So you can be, going along doing something repetitive, and then a bit of the cortex will actually go to sleep. So I think there's been huge advances, and I think it's wonderful that our two communities now talk to each other and work interchangeably.
Yeah, so before we dive into understanding what are circadian rhythms, what is the biological clock, and so on, I was also wondering whether you perhaps have some insights into how did our approach to sleep change on a more behavioral level. So I don't know, in the way we think every day about sleep. So
Yeah.
perhaps, like for example, in the professional environment, would you say that before there was perhaps it was more acceptable for people to, for example, sleep less? Was there a bigger pressure on us to work more and sleep less than it is today? Or would you say that the trend did not really change? What is your view on this?
Oh, well, as you pointed out, I've been in this field for quite some time. And so what's been absolutely clear. I remember in the 80s, people would say, "Oh, I've done another all-nighter," and it was, "Oh, fantastic, well done, what a hero." Sleep was for wimps. It was an indulgence and a luxury, and we really didn't understand what was going on within the brain whilst we slept. So we then get to the turn of the century when attitudes have changed. People were beginning to take sleep more seriously because of the emerging neuroscience showing that memory consolidation, the processing of information, and most recently the clearance of specific toxins is all going on within the brain. And indeed, so many observations were being made about what happened to your biology and your behavior in particular if you didn't get the sleep that you need. And so there has been a profound change. So now if anything, I think there's been something counterproductive, which is there's something called sleep anxiety, as I'm sure you know about. And so people have become so obsessed with their sleep that they're frightened about getting to sleep, if they wake up, of getting back to sleep, and how long they've slept. And I hope we're now going into the time where we regard sleep as a very dynamic, changeable behavior, and that we shouldn't get worried if we have one bad night or whatever. And the fact that sleep is like shoe size, one size does not fit all, and each of us needs to address our individual sleep needs and then tailor our behavior around those needs. It's got a bit worrying at the moment, with lots of people terrifying themselves about. I've had people come up to me and say, "I don't get 8 hours of sleep. Am I going to die?" And I say, "Well, yeah, you're going to die, but it may have nothing to do with the number of hours you've slept." It's that. And should I look at a Kindle before I go to bed? And it's those sorts of myths that seem to be. I was speaking to a journalist earlier today about melatonin. And you sit in and you hear time after time, melatonin is a sleep hormone. It is emphatically not a sleep hormone, as we know from the biology. But yet these myths seem to sit there, and it's very difficult to displace them.
That's true, and that's exactly what you said. So there is like a sleep anxiety, and very often it actually disturbs our sleep because we're so stressed about falling asleep. And if you wake up in the middle of the night, we're like, "Oh my God, no, I'm never going to get enough sleep, so I will be tired."
It seems that we now think about sleep as this sort of this thing we should subdue and bludgeon into submission, rather than sort of embracing and giving it a good old cuddle and enjoying what respite we can get with our sleep.
Yeah. All right. So perhaps further on, we will talk about the facts and myths regarding sleep, like what I've heard, what people have also told me, and I would like to confront it with you.
Yep.
Before we do that, perhaps you could explain what is the link between circadian rhythms and sleep?
Yeah. So there are two timing processes involved in sleep. And I should step back. Sleep, of course, the transition from consciousness to sleep and sleep to consciousness involves a complete realignment of essentially all the transmitter systems within the brain, giving rise to the states of consciousness and sleep. Both very complicated states. Sleep is not simply shutting the brain down, as you will know. Some areas of the brain are more active while we sleep than when we're awake. But what's the timing of the two transition states? One is the circadian system, and you can think of it as saying now is the appropriate time to be awake and now is the appropriate time to be asleep. So it provides an empirical timestamp to sleep. But there's of course another process, which has been called the homeostatic drive or sleep pressure, which is the longer you've been awake, the greater the need for sleep. So what happens is you wake up in the morning and the sleep pressure rises and rises and rises. You don't fall asleep because the clock is saying it's daytime, be awake, be awake, be awake. It's only as you approach sleep time that when the sleep pressure is incredibly high, and interestingly, of course, to compensate for that, the circadian drive for wakefulness is at its highest just before we go to sleep. The clock then says, okay, now's a good time to sleep. The sleep pressure kicks in, and as we sleep, the sleep pressure declines, and the clock is saying, stay asleep, stay asleep, stay asleep. And then as we approach morning and wake time, the sleep pressure is very low and the circadian drive for wakefulness kicks in and we wake up. So there is this incredibly interesting dynamic. Now, one of the things that we've been interested in is, well, what is the sleep pressure? And so we've shown that it's a buildup. Well, not we, but others have shown previously, and we've confirmed it, that the buildup of adenosine within the brain is a very important signal which determines that homeostatic drive for sleep. So that's interesting. But what's also fascinating is that high levels of adenosine, decrease the clock's sensitivity to light. So the longer you've been awake, the more insensitive you are to light. So it's not that just the clock is driving sleep, but sleep is actually talking to the fundamental mechanisms that are regulating the clock. And that, I think, is so exciting, because these aren't isolated bits of our physiology. They're talking to each other. And the more we understand, the greater we see of the interactions between these two remarkable behavioral systems.
So you talk about the sleep pressure and how it's increasing throughout the day, and it's supposed to be the biggest when we're supposed to go to sleep in the evening. So how come sometimes we have this afternoon crash where we are really tired after eating, or
Yeah.
just in the afternoon?
Well, in fact, this mid-afternoon dip can happen whether you've had a boozy lunch or not. And I would explain it by saying we haven't quite had the full bunch of sleep that you needed the night before. So what's happening is the sleep pressure is high, and the wakefulness drive from the clock isn't keeping up with it. And so you crave that sort of mid-afternoon sleep. And what's so fascinating, of course, a short sleep can push back the sleep pressure and actually make the second half of the day more profitable in terms of what you want to do. So yes, these two systems are interacting, and it's a mismatch in a sense. The sleep pressure is so high that the circadian drive for wake can't quite keep up for it.
Okay, so an afternoon nap would solve the problem.
It would, but it's got to be the right sort of nap. It can't be too long. So the data suggest it shouldn't be longer than 20 minutes. Otherwise, you fall into a much deeper sleep, and then recovery from that, or waking up from that, leaves you groggy. And there are sort of important implications, not least for teenagers. So teenagers, for a range of reasons which we can go into, tend to want to go to sleep later. It's exaggerated. Their biology is exaggerated by social media. So they're getting quite limited nighttime sleep. They're being driven out of the bed in the morning by their parents or an alarm clock. They struggle through the school day. They get home, then they will have a long sleep. And of course, what that does is push back the sleep pressure for that night. And so you get shortened sleep during the night, longer daytime, naps or sleeps. And so you can fall into an actually very unhelpful feedback loop, which is really very counterproductive for certainly learning stuff in the classroom.
Yeah. That's totally true. Also, I have a teenage brother, so I can also observe his body clock and his circadian rhythms. And it's true that he wakes up at 1 p.m. very often at weekends. So for me, it's extreme, but I guess it's just his biology.
Well, yes. I mean, the problem is, of course, is that yes, and we should unpack this. So there's our chronotype, when we want to go to sleep and when we want to wake up. Our genes, of course, contribute to that, and there are subtle changes in some of the clock genes which have been associated with morning people versus evening people. There's our development, which is as we go from the age of 10, we tend to want to go to bed later and later and later. In women, they peak in their lateness around about 19 and a half. Men around about 21. And men tend to go to bed later than women on average. Then there's a move to a more morning phenotype. And so the time we're in our late 50s, early 60s, we're getting up and going to bed at about the time we got up and went to bed when we were 10. But it's important because there's about a 2-hour difference between somebody in their late 50s and compared to when they're in their late teens, early 20s. And the third factor is light. So light, of course, sets the body clock to the external world, but it has different effects. Morning light advances the clock, makes us get up earlier, go to bed earlier. Dusk light delays the clock, go to bed later, get up later. So we do have some control over our sleep-wake timing by when we see light. So if we're a late type, we set the alarm, you get morning light that advances the clock, which means it's easier to get up. Now, going back to your brother who's sleeping in until 1 o'clock, and I hope he listens to this, is what's happening, of course, he's missing that morning light, but he's getting light in the afternoon, which will shift his clock later, which will mean it'll be more difficult to get up on that Monday. That's why the advice is try not to oversleep at weekends, particularly if you're going to miss that morning light, which is so important in advancing the clock and the sleep-wake cycle earlier in time.
Okay, yeah, I'm sure that he will be listening to this. I will tell him to
What's
listen.
his name?
It's Oscar.
Oscar, right. Okay, Oscar, listen to that.
Yeah. Okay, so if I understand correctly, we have a body clock which is oriented or which is guided by light above all.
Yep.
And the way our body clock works can be is dependent on our genes in part. Yep. So we can be either larks or night owls, and it's a fact.
Yep.
But we can also steer our body clock towards one direction or the other by exposure to light in different parts of the day.
Exactly. Yes.
Is the light that we can expose to it, does it matter if it's artificial or natural? What I mean is that even if we would have artificial light which is extremely bright, can it replace? Is there a kind of artificial light that could replace the natural light?
The short answer is yes, but it sort of unpacks an extremely important question. What's the nature of the light, its intensity, its color, its duration that's required for the regulation of the clock? And it's turning out to be complicated. On average, the clock needs relatively bright light for a long duration to entrain properly. And this has led to some confusion because there are recommendations out there saying that you shouldn't get bright light in the evening because that will shift the clock. That's generally true, but it depends what you mean by bright light. I think bright light, and we're talking hundreds of lux, not average room light, which is about 90 lux, or the amount of light you get from a Kindle or a light emitting book, which is about 30 lux. So bright light, long duration is what seems to be required. And of course, what's happened is we're tuned to the sorts of light we'd see in the natural world. So we live our lives in dim, dark caves. I mean, I would urge your listeners to go and buy a lux meter and then just sort of open it up, or you can actually download them on your phone. I've got one on my phone here, which I get out from time to time. We're living in my office is probably a couple of hundred, maybe 250 lux. If I went to the window just over there, it would be over 3,000 lux. And outside, even on a grey day in England, you're going to be 10,000 lux. And on a sunny day, even in England, you'll get to perhaps 100,000 lux. And so the clock is looking for bright light at dawn and dusk. The changing quality of light, the color of light are also known to be important. How precisely, we don't know. So we really don't have a good handle on the biology to provide recommendations, specific recommendations about the light we need to see or not see in the home in the evening. I think the rule of thumb is, yes, keep the lights relatively low because, of course, light will not only shift the clock, but it'll increase levels of alertness, as you know. But how low is not exactly clear.
So it means that perhaps we actually can look at screens before going to bed. There is no evidence that looking at screens may delay our
I think this is really, really important. And so if we look at the study that came from Harvard a few years ago, and they looked at a Kindle, and participants were asked to look at a Kindle for 4 hours immediately before sleep at its highest intensity setting on 5 consecutive nights. Now, there were effects on melatonin, but sleep-wake timing was only delayed by barely statistically significant 10 minutes at the end of those 5 days. And a paper published by another group a few years later has shown that if those individuals were given something like 500 lux during the day for a few hours, those subtle effects that you see with dim light in the evening are completely abolished. So it adds another factor. Our sleep history is going to influence the sensitivity of our clock in the evening. For most of us, if we're getting some relatively bright light, going outside for lunch or whatever, we're probably not in danger of shifting the clock with screens and Kindles and smartphones in the evening. Now, that's shifting the clock. What, of course, smartphones and Kindles and gaming stations, as your brother might be using, will be increasing the alertness in the brain, and that will mean that it'll take longer to get to sleep. So device use is complicated. Try not to use it. It's not so much the light, but it's the alerting effect these devices have on the brain.
Mm. Tell me, why is our body clock 24 hours?
Well, it's not exactly 24 hours. So if we look at all organisms that have been studied, and you put them under constant conditions, let's say constant dark, you'll see that it can be longer than 24 hours, as in humans, by around about 24 hours, 10 minutes, 15 minutes, or it can be shorter than 24 hours, as in a mouse. Many mice have a period under constant conditions of 23 and a half hours. Now, I don't fully understand the mathematics of this, but I am told that if you have one fixed period, which is the environmental 24-hour day, and a slightly different period, which is the biological clock, it's easier to align the clock if it's slightly different from 24 hours than if it was exactly 24 hours. So it's we don't want our clocks to be exactly 24 hours because we want them to be able to align easily with the astronomical day. And I'm told by my mathematically inclined friends, it's easier to align two oscillators if one is slightly different in period from the other.
Okay, but we don't know why. I mean, it's probably synchronized with the movements of the Earth and the Sun and so on, right? Because this is also what we like. It's nearly 24 hours among the majority of species.
Exactly, yes. Yeah. And it's quite interesting. There are trends. So diurnal day-active mammals tend to have longer body clocks, a little bit longer than 24 hours, and nocturnal tend to have shorter body clocks. And that's probably because of what's important in terms of when you see light. So dusk light delays the clock, makes you get up later. Now, a mouse is emerging from its burrow. It's normally getting up under constant conditions earlier and earlier and earlier. So every day it needs to delay. And so what's happening is dusk light delays the clock. Whereas for us, it's the opposite. We're advancing and advancing, and we need to do the opposite. And so that's why I think the nocturnal and diurnal animals are different because of when they need to entrain.
Mm. Yeah, it's fascinating, right? How it all works in biology.
Yeah, because our clock, we'd be getting up later and later and later and later. Yeah. And morning light advances the clock. It shoves it in this direction. And that's what we need every day.
Yeah. Also, we've mentioned larks and night owls, and this is something that's personally interesting for me because some time ago, my boyfriend told me that actually it's not true, that there is no such a thing like a night owl or a lark, because he's more of a lark and I'm more of a night owl. And so we have an ongoing argument about at what time should we go to sleep, because he can't sleep if I'm not sleeping.
Okay.
So we're really trying to match our sleeping
and so what's your boyfriend called? What's his name?
Michael.
Michael. So you need to, again, get Michael to look at this. So there is a biological basis for morningness and eveningness. We've talked about the fact you can adjust it a little bit. There is some data, interestingly enough, and I don't know if I believe it or not, that the longest surviving relationships are between morning people and evening people.
All right.
Now the cynic might suggest that's because they don't see much of each other. I think the explanation is if you can accommodate the sleeping habits of your partner, It shows you've got that flexibility to deal with all of the other rubbish and
Yeah,
ghastly
very hard.
stuff that is thrown at a relationship.
Yeah.
Yeah, I think it's important. And bed sharing is a very interesting issue. Um, uh, so of course, as you get older, there's a greater chance that one of you might start to snore. Um, and under those circumstances, my advice is very clear: find an alternative sleeping space. Obviously, check that your partner doesn't have obstructive sleep apnea, which needs to be fixed. But
Yeah.
an alternative sleeping place is not an indication of the failure of a relationship. It means you've again got the flexibility. You both get a decent night's sleep. One isn't irritated by the other, which means that in the morning you can get together for your cup of coffee and croissant or whatever it is and enjoy each other's company rather than resenting your partner after a bad night's sleep. So, yeah. And of course, bed sharing has not been the norm for many societies. In Japan, for example, married couples will often sleep apart. The aristocrats of Europe never slept in the same sleeping space.
Yeah, that's true.
I don't think it's something we should get too worried about.
And what about going sort of against your natural sleeping schedule? Do you think that if one of us forces our sleeping schedule, so either goes later to sleep or goes way earlier, and so sort of go against, so if I go against my habits, my nature, can it be harmful?
It is difficult. I mean, what will happen is, of course, you'll try to go to bed early. You'll lie there, unable to get to sleep, getting more and
No,
more.
but I can go to sleep.
Oh, you can.
I can.
Okay.
Yeah, it's not that I can't go to sleep. It's just that,
Okay.
like, in the morning, I'm really, I'm sort of unconscious when I wake up, and
So your sleep duration is longer than your partner's.
a bit, yeah, but not that much longer.
Yeah. But I mean, in a sense, I guess there shouldn't be any hard and fast rules. I mean, if it
Okay.
works, that's
If it
great.
works, then
But
okay.
I mean, the point though, the bigger point is overriding this deep biology. If you're a night shift worker, for example,
Yeah.
and it's assumed that, of course, that night shift workers will adapt to the demands of working at night, and of course they don't. And we go back to light. What's happening, of course, there's relatively dim light in the workplace. Then the individual will experience relatively bright, natural light, on the drive home or in the evening, and the clock will always defer to the brighter light signal, the environmental signal, as daytime, which of course it is. So night shift workers don't shift. They can shift if you increase the light in the factory. This is some work from Harvard, and you hide them from natural light during the day. Then, just like getting over time zone changes, you will adapt. But that is practically not really an option. And of course, if you're working at night, when your biology is saying you should be asleep, to overcome that, you're activating the stress axis. And of course, sustained activation of the stress axis, it leads to a whole range of health issues. I mean, the stress axis gets a bad rap. It's wonderful. I mean, it's a bit like the first gear of a car. You go into first gear, you got that wonderful acceleration, you go out. But if you keep the engine in first gear, you're going to destroy it. And that's similar to what's happening on the night shift. You're keeping your stress axis on full throttle to try and overcome this biology saying you really should be asleep. And that's where the problems, in immune suppression, cardiovascular problems, high rates of cancer. It's worth bearing in mind that the World Health Organization has now designated night shift work as a probable carcinogen, which I think is fascinating. So, yeah, I mean, by ignoring our circadian rhythms and our biological rhythms, we can certainly make ourselves much more vulnerable to illness.
So even if I continue to work at night, I can't get used to it. Like, it's not that I can I entrain my organism to be active only during the night, or it's always harmful because of the lack of the natural light?
Well, you can, of course. I mean, you can shift the clock. We do that when we travel across multiple time zones, and it's the light in the new time zone that is primarily responsible for allowing us to adapt. But it's really difficult. Changing your chronotype within a specific time zone, unless you selectively look at light at dawn or dusk. I mean, we did some studies a few years ago on university students around the world, and this is Kate Porchette. She's a wonderful study, and she showed that the later the chronotype these young people were, the less morning light, which would advance the clock, and the more evening light they got. So part of the delayed rest activity is due to when you see light exposure. So that's the bit we do have some control over.
All right. What is central to my activity here, I would say, is the question of how does sleep affect our mood and affect. Why are we, for example, grumpy if we don't sleep well?
Well, Well, of course, most of our understanding of why sleep is important has been defined on the basis of what happens when we don't get it. And of course, as you rightly point out, if we think about our emotional responses, then after even just 1 or 2 nights of poor sleep, we can see fluctuations in mood, increased irritability, increased anxiety, loss of empathy. We don't pick up the social signals from our friends, family, and colleagues as easily. We do stupid things. We undertake risks, and we do impulsive, stupid, unreflective things. So, we'd be driving. Oh, yes, I can get through the traffic light before the lights change. No, you can't. You'd never do that when you were fully rested. But you think, oh, yeah, I'm going to make it. Of course you can't. It's daft. Negative salience. This is so important. Jan Bourne has done some wonderful studies showing that the tired brain remembers negative experiences, but it forgets the positive ones. So one's whole worldview when you're tired is being based upon the remembrance of more negative experiences. You're more inclined, of course, to use stimulants to drive the waking day, and then sedatives to reverse that later on. And that can blend into illegal drug use. So some very important emotional effects. Cognitive responses, well, of course, our overall ability to process information, make decisions is down. Our ability to multitask, I think this is a very interesting one, which is what we have to do all the time is select from a whole barrage of information that's coming in, what's relevant and how to respond. That falls apart when we're tired. Our ability to consolidate memory is gone. But also our ability to process information. So to come up with innovative solutions to complex problems is also badly affected by tiredness. Concentration, communication skills, decision-making, productivity, all of that is affected by just a couple of days of not getting the sleep that we need. Long-term, as we've discussed, as in night shift workers or the banking community or academics, is that microsleeps, falling asleep uncontrollably at the wheel. Very interesting study showed from the UK that 57% of junior doctors had either had a crash or a near miss on the drive home after the night shift, which is just huge. We've talked about cardiovascular disease, stress responses. I haven't mentioned metabolic abnormalities. Really, what you find in so many night shift workers, type 2 diabetes, obesity, and other metabolic problems. I also haven't talked about the vulnerability to mental health issues. It's really interesting that for depression, for example, you see a change in the pattern of sleep prior to a depressive or psychotic episode. We did some studies a few years ago on, again, university students who were showing poor sleep, and they were exhibiting features of paranoia and hallucinatory experiences. And we were able to show that just by partially consolidating their sleep, levels of paranoia reduced, delusional experiences reduced. So there's a very, very important relationship between sleep and mental health. And you can slide rapidly into a dangerous state in terms of mental health because your sleep is actually distorting all of those, the biology that we've talked about.
Yeah, I think it's so important, and it's also something that is easily manageable. Like if we get to know that the maybe let's say rules, although I do not really want to use this word.
No,
but guidelines on like how to get a good night's sleep. Perhaps it's something that we can implement ourselves, right? If we
That's the point. And of course, the point about the book Lifetime was not to say you must do this, you must do that. There's a massive stuff we can do. So many people think that sleep is just what you get. Actually, it's a dynamic behavior that we can change, and we can change it as we feel we might need to change it, but not by somebody like me saying you've got to do this, you've got to do that. That's deeply unhelpful.
There's also something interesting for me that I wanted to discuss with you, which is, for example, the phenomenons such as winter blues, being winter blue or something like that, which is so like is that we seem to not get enough light, and as a consequence, we experience like a lower mood. So perhaps like a bit of depressive episodes. Could you elaborate? Could you tell me what?
Yeah, I think in the beginning, when seasonal affective disorder, which is the extreme form of winter blues, first surfaced, there was some resistance, and some psychiatrists still don't believe it. They just don't think it's a thing. But of course, supplementary light has been shown to reduce both seasonal and non-seasonal depression. A very interesting study compared individuals who were depressed. They were given a placebo, they were given Prozac, or 30 minutes of light at 10,000 lux in the morning. By 8 weeks, Prozac was statistically significant from placebo. But for light, it was statistically significant from placebo at 2 weeks. And then at 8 weeks, it was very different from Prozac. What was fascinating is that individuals on Prozac and light therapy, the results seem to be additive, suggesting that maybe light and Prozac are interacting with the pathways in the brain mediating depression, but in different ways. So I'm pretty convinced that there is indeed such a thing as seasonal depression, the winter blues at one end, and full-blown SAD, which is really crippling, where people are so overwhelmingly fatigued that they can barely get out of bed. They just want to get out of bed and eat. And so it's very, I mean, having talked to those individuals, really fascinating. And you sort of say, well, why isn't the suicide rate higher during that period? And they say, well, you just don't understand. We are so crushed by seasonal affective disorder that we don't even have the energy to devise a suicide attempt, which I think is fascinating and yet chilling at the same time. There's one idea that as the days start to get longer, there's a different effect on one's biology, so that the mood, the depressed mood, and the energy levels are changing at different rates. So with increasing spring day lengths, energy increases, but you still stay depressed. And that may explain why suicide in the northern hemisphere is peaking in March, April, because to the increasing day lengths, energy is increasing, or motivation or whatever, but you're still depressed. And I think it's so important that people who are vulnerable to these conditions are aware that this is the danger zone, and that they need to really appreciate that they are most vulnerable at that time.
Yeah, that is fascinating. And so do you think that light therapy could solve part of these issues?
Yes, I do. I mean, and there are lots of examples of this. The people of northern Norway in Tromsø, and I've been lucky enough to visit, and you see that in many of the homes, in the morning, there's a light room. That's where they go in, they use artificial light. That's where they have their breakfast, the whole family. They chit-chat, they eat their breakfast, and they're getting their photon shower, their morning shower of light to set the body clock and the sleep-wake cycle. And I think it can certainly be a useful alternative. Yeah, absolutely.
And what kind of light is it?
That's another great question. As long as it's bright enough, it doesn't matter what the color is. Okay. And there's a big misconception that you only have to have blue light, because that's the wavelength of light of the receptors that we discovered in the eye, these photosensitive retinal ganglion cells. But they have a bell-shaped response curve. They peak in the blue part of the spectrum, but they can absorb longer and shorter wavelengths. So if it's bright enough, it really doesn't matter what the wavelength is. And a lot of money is being made, by companies selling sad lights which are enriched in blue. Well, actually, it's not necessary. You just need to either get outside or use a bright white light.
All right, that's useful to know. Also, I wonder about those sunrise or sunset lights. What's your view on those?
Yeah,
Do you
I
think
think
it's just a marketing product, or are they really
no.
useful?
There is some data, and it started a while ago. There's a paper a high-profile paper showing that if you gave people either a ramped up sort of dawn simulation versus a square wave, then people woke up feeling far better with a dawn simulation than an abrupt change in light. And that dawn simulation was much more effective in training the circadian clock. And I think that we don't know how, but it kind of makes sense because what biology does is fine tune to the specific stimuli in the environment it needs. And of course, what it wants to detect is the phase of dawn and dusk. And so by having the ability to ramp or measure a changing intensity, I think makes an awful lot of sense.
Just a quick break. If you would like to engage in a small act of kindness yourself, go and follow us on Instagram. It will help us grow and develop this initiative. You can find us under the name Joyful. That's spelled with 10 U's. And if you're feeling particularly generous today, consider rating our podcast on the platform you're using to listen to us. It only takes a few seconds of your time, but it will bring a huge smile to our faces. Enjoy the rest of the show. Okay, so if we know now, more or less, at least, how does sleep affect our well-being, or how does it contribute to our mood levels during the day and to our overall health, perhaps we could discuss what is a good night's sleep. So this would perhaps be the part where we discuss all the myths and facts regarding sleep.
Yeah, I guess, well, how do you know if you've had a good night's sleep? Well, it's kind of advice our grandparents would have given us, which is if you're able to function optimally during the day, you probably have the sleep that you need. If you oversleep extensively, as your brother does on free days, he's not getting the sleep he needs during the week. If you need somebody to get you out of bed in the morning, an alarm clock, and you're not waking naturally at an appropriate time, you're not getting the sleep you need. If you feel sleepy and irritable, if you crave a nap during the day, if you're doing stupid and unreflective things, those altered behaviors, if you crave sugar-rich and caffeine-rich drinks, and also listen to your friends and family. Are they saying, you're a bit more irritable, you don't seem to be as engaged as you are normally? That's all telling us they're not getting the sleep we need. So, what do we do? Well, we, I guess, try and go to bed earlier and extend our sleep. And there's loads of things you can do about that. I mean, as we just touched on, most people don't have a sleep problem. They have an anxiety or a stress issue. And so it's winding down before you go to sleep. And again, whatever works for you. It may be listening to some relaxing music. It may be a warm bath, which has some interesting physiological effects. It may be a few pages of Jane Austen, whatever, winds you down and transitions. And then, of course, you can define the sleeping space effectively by making it a haven for sleep. Now, the problem is that during lockdown, so many of us have turned our bedrooms into offices. But really, you need to get rid of that distracting stuff. And if you can, just take it outside. Leave your smartphone out. Anything that is going to make you more alert and generate anxiety, you've got to get rid of. Some people define the sleeping space with a distinctive smell, like lavender or something. Now, the evidence behind that is increasing, but it's not great. But it makes sort of psychological sense that, I associate that smell with relaxation and sleep. Buy decent mattresses and bedding. I mean, it's interesting. I don't know about where you're living. Well, you're living in France at the moment, and you're off to Switzerland. Well, I don't think the Brits really take their mattresses and pillows seriously. I think they resent spending hundreds of pounds on a decent mattress or pillow or duvet.
Why is that?
I don't know. I mean, a third of our lives are going to be spent in bed. Why don't we produce this wonderful, glorious cocoon of sleep? I think I don't know what it is. So I've been, trying to spread that message.
Yeah. Well, personally, I really like going to those German hotels or like Western Europe hotels where you have, like German is really good. Actually, they have amazing beds usually, like in the hotels, amazing beddings, and it's really comfortable.
And you're completely right. They're big and they have 2 duvets. So couples don't have to share, pulling the duvet backwards and forwards. And I've been saying this in the UK for, because I worked in Germany in the early mid 80s, and if they had sensible duvets even back then, and we still don't have those in the UK. It'll be a single duvet, which is just bizarre. So waking up in the middle of the night is I think, a major concern for many individuals.
Yeah.
And so Roger Ekirk has written a book at Day's Close where he's documented historically lots of examples of where human sleep patterns, which followed the light-dark cycle to a much greater extent than we do now, would fall into a pattern of what he calls biphasic and polyphasic sleep, which is that you go to sleep, you wake up, you go back to sleep again, and all the rest of it. Many people, if they wake up in the middle of the night, think, oh my God, that's it. I'm never going to get back to sleep. They get all stressed. They start doing emails, drinking coffee, and all the rest of it. And you're laughing because I suspect this may be what you.
No, I've never done that. I really don't have any problems sleeping, so I don't wake up in the middle of the night. But my partner does. Like he wakes up a lot, and he gets stressed that he won't fall back asleep. And I'm just like, well, just go back to sleep and don't worry about it. And
exactly. That's good advice. I mean, maybe he wants to leave the bed for 20 minutes or so and chill and relax and then fall back to sleep again. What I do is there's a wonderful BBC program which plays all of the old plays and stuff. So I listen to something relaxing, an Agatha Christie, something gentle, some gentle murder mystery, and I'm usually asleep again in 10 minutes. And again, you work out what works for you. But it's probably, what was fascinating is that during COVID, many people, of course, had a longer period to sleep. So they expanded the sleep episode and they reported worse sleep. And that's because, of course, they were waking up completely stressed about family, friends, their business or whatever, and not getting back to sleep again. So it was ironic that the greater the opportunity to sleep led to more biphasic or polyphasic sleep, which, because people didn't know that was the default state, made them anxious and therefore made their sleep worse. It's worth bearing in mind that Tom Weir in the States, he put young people under 12 hours of light, 12 hours of darkness, and he found that they became polyphasic sleepers. And so given an expanded opportunity to sleep, then, it's very likely that you will wake up in the middle of the night. Now, there's additional things. If you're old, then, of course, many people need to get up in the middle of the night and pee. Well, maybe. The argument is interesting because you wake up, you're aware there's bladder in your urine. Sorry, there's urine in your bladder. Sorry.
The other way around.
Spoonerism. Yeah, there's urine in your bladder. Thank you. And then they think, I better go up and pee. They haven't woken up to pee. They've woken up and then think that they need to pee. But one of the things in nursing homes, which is really important, is that if you're sitting in a chair or wheelchair or something all day, then your blood pools into your ankles and their limbs. And then, of course, you need to lie flat when you go to bed. And that blood, plasma, if you like, is then reintegrated into the body. And so you have that great, integration of fluids. And in fact, just by lying down after a day of inactivity, and if you're slightly hypertensive, you can generate 1 liter of urine. So no wonder you need to get up. So that's why it's very important for elderly people to stay mobile during the day so you don't get those puffy ankles and swollen lower limbs.
Mm. And going back to the fact that we have this polyphasic sleep if we are placed into the conditions where it's dark or like dark all the time, for example. I've also heard that it's how people in Middle Ages and in general before the industrialization period were sleeping. Is that true? That we used to
Well,
have
we
a
think
completely
so.
different sleeping pattern?
Yeah, I mean, certainly Roger Eckert, who has been the pioneer in this area, would argue that. And it's worth bearing in mind that prior to the modern era, light was amazingly expensive. A candle was made out of animal fat, and people were on the borderline of starving most of the time. So you certainly wouldn't burn animal fat, you'd eat it. And the cost of a candle in the mid 19th century, as I understand it, was something like a penny. Now that's near the equivalent of an average working man's daily wage. So you couldn't afford artificial light. And so people went to bed and woke up much more in attune with the natural light dark cycle. And there's evidence that the sleep cycle expanded during the winter months and contracted during the summer months. So again, it's all about kind of being in tune with our environment and our biology.
Okay, so regarding the good night's sleep, we should above all listen to our feelings. So see
Yes,
if we feel good or if we feel bad, and then decide whether we want to introduce any change in our sleeping
exactly.
patterns and sleeping habits. We should probably chill, to say it in a more colloquial way,
Yeah,
and see what sleep patterns suits us best. I think you've already mentioned that at the beginning of the conversation, but perhaps it didn't really stick with our listeners, which is that there is no one hour time frame, right, for
absolutely.
everyone. So we all have different sleeping schedules. Is there, however, a recommended amount of time that you would say exists?
I
Or
wouldn't put a number on it. I would say,
yeah.
natural, healthy sleep can range between 6 hours and 10 and a half, 11. And it's for us to define what we need and then defend it. And of course, it's really tricky. So if you ask a lark, what does your work interfere with your sleeping patterns? They say, no, no, it's easy. I get up and I go to work and all the rest of it. If you ask them, does your social life interfere with your preferred sleeping patterns? They say, oh, it's dreadful. All my friends want to go out on a Friday night or a Saturday night, and I just want to go to bed. And I just so yeah, you have to. I mean, it's tricky. Of course, and it's the reverse for owls. Work is a problem, whereas social life, now they can stay up all night and party. So it is an issue, but within certain boundaries, we can just. I mean, there was a book out a few years ago which suggested you can't possibly ever have a late night. You've got to have an absolutely rigid regime. Well, I just would disagree with that.
Mhm.
It's a dynamic, flexible behavior.
Mhm. And also, I was wondering whether you could comment on the three factors that I've learned somewhere along the way contribute to our sleep, which are hormones,
Hmm.
then there's temperature and light. So we've already discussed light quite a
Yeah,
lot, but then there is temperature. So I've actually learned that temperature can best predict, for example, when will we wake up, and this is
yeah.
like the
I think
best.
it's temperature is really interesting because as we approach sleep, core body temperature drops. And it only changes. It goes from let's say 8 o'clock, 9 o'clock in the evening from its peak to its lowest point at around about 4 o'clock in the morning. And of course, that will change depending upon the individual. And it seems that drop in core body temperature is quite important. And if it's blocked and we stay too hot, it's more difficult to get to sleep, which is why some people would recommend, a warm but not hot bath, because it dilates the blood vessels in the skin, which means that we shunt blood from the core to the periphery, and with that blood we take away heat, which can help reduce, that core body temperature. So, and of course, in the morning it starts to rise in anticipation of increased metabolic rate with activity. And so, yes, it could well be that a sort of a subtle rise in core body temperature is one of the factors that we use to wake us up in the morning.
Mhm.
Absolutely. Yeah. So that's temperature. We've talked about light being really important.
Mm.
Hormones. very interesting. We've said that melatonin is not a sleep hormone.
Yeah, could you explain what is it then?
Well, it's a very mild modulator. So if you think about it, I mean, what do the data show? Well, if you take the study which showed the greatest efficacy was something like 3 milligrams of melatonin 30 minutes before bedtime, and it speeded up the rate at which you went to sleep by 20 minutes or so. Most studies have shown no effect. So it can have an effect, and it can have an effect in some people. So it can increase sleepiness a bit, and you'll fall asleep. So that's what it seems to be doing. It's probably also interacting with light to enhance the effects of light on the clock. So it has been used, for example, as a jet lag agent. But again, some people report no effects, others a little bit of an effect. So what we know about melatonin, of course, is that in mammals, generally, going back to comparative biology, it's the expanding nighttime pattern of melatonin during the autumn and winter and the contracting melatonin profile during spring that reflects day length, and that can trigger reproduction. So in autumn, you get the rut, you get sheep breeding as the expanding melatonin profile, so that you get conception. The young develop over the winter, and they're born in the spring when there's lots of grass production to sustain milk and weaning. But of course, if you're a small mammal, like a hamster, then it's the decreasing melatonin profile, the expanding day length that acts as a trigger. And so melatonin in seasonally breeding mammals is absolutely central to their ability to time their reproduction appropriately. So yeah, mild modulatory effect on humans, big effect on seasonally breeding mammals. Yeah.
Right. What other hormones do we have? I heard about cortisol, testosterone.
Yeah, and of course, if you're stressed, cortisol will not help sleep. One of the most interesting areas that is sort of emerging is the female reproductive hormones. So you see a change in sleep across the menstrual cycle. So around about ovulation, when estrogen levels are high, you get good sleep, and estrogen has been associated with relaxation and sleep. And progesterone is also high because it follows after the LH spike in ovulation. You get high levels of progesterone for a short period, and that's thought to decrease anxiety. So you tend to get good sleep and relaxed sleep around ovulation. But before and after menses, you get worse sleep when progesterone and estrogen levels are low. We also know, very interestingly, from mouse work, they have a 4-day estrus cycle where estrogen and progesterone are changing levels. And you can predict exactly where the mouse is in its estrus cycle because of when it starts to run in the running wheel. They will advance and delay activity onset. And one of the things I'm working on at the moment is how males and females differ, and how the estrogen receptors in the female SCN, master body clock, are influencing circadian behavior. So there's some really interesting data emerging there. And of course, if we think about the poor sleep associated with perimenopausal and menopausal women, again, those hormones are all over the place. And they can also affect temperature. And as we've said, temperature can be very important. So you might get a night sweat, which means your temperature has risen, which means that you're more likely, therefore, to wake up. So yeah, there's a very interesting, but still to be clarified, interaction between female hormones and sleep and their impact upon circadian timing.
Well, I think that we've only scratched the surface, but I invite all the listeners to read your book because I believe that it's all explained there in way more details if someone's interested in that. And before we finish, as we're heading towards the end of our conversation today, I wanted to ask you, how do you think our understanding of our sleeping patterns and of circadian rhythms and so on can contribute to our happiness levels in our everyday life?
Well, I think it's important at every level. And I feel that our political masters need to embrace sleep. They need to be creative. They need to be interactive. They need to have a good sense of humor. They need to have low levels of irritability and impulsivity and anxiety. And so, we've got to get the message out that across all levels of society, we embrace sleep. And by embracing sleep, we protect some of the fundamental things that make us human: our sense of humor, our ability to reason, our ability to interact constructively with others. So, sleep is the best cognitive enhancer known to humanity.
Yeah, and all natural, right? Also.
Yeah.
Mm. Okay, well, thank you very much for this exchange. I invite all our listeners to check out your different works, articles, books, publications, as it's truly fascinating. I think for all of us, sleep does concern us all. And I wish you a nice day and a great continuation in your work.
Thank you so much. It's been
Yeah.
great fun chatting to you.
Okay, cool. Thank you.